All right, smog. This is directly correlated to thermal inversions. So I just wanted to start with this because we finished here. Temperature inversions. So the normal thing should be warm, cool, cool, and pollutants will rise and kind of dissolve outside of the troposphere. But sometimes a warm layer of air forms in between the cool. So it inverts. I would say cool comes to the bottom, warm comes to the middle. And the pollutants, instead of rising and kind of breaking apart and exiting the troposphere, come back down and stay stagnant here. And a lot of times this contributes to smog, which I'm going to talk about today. I just wanted you to make sure you understand that temperature inversions promote smog, okay? In addition to other things. So we're going to talk about 4 major global air pollution problems. And like I said, we're going to start with smog. We're also going to talk about what? Acid precipitation or deposition or rain, as most people know it. What else? What's a big problem in our stratosphere? Ozone depletion. And then our big problem with climate is climate change and global warming. Good. Which has contributed usually, a direct relation to greenhouse gas emission. So photochemical smog is basically trapped pollution in the troposphere closest to the geosphere. So it's literally a layer of dirty fog that hangs over land. And it's usually in areas where there's high traffic and a lot of cars and a lot of buildings, okay? China has a huge problem with smog to the point where they have daily reports of whether you should exit your house because the levels could be so high. I'm going to just jump here. In the U.S. and on the AP exam, L.A. is known as one of the worst situations with smog in the United States since about the 1965 through 2010, believe it or not, where they did a super duper intense emissions regulations, and they did pretty much clear out the problem. So what is smog? Or how does it happen, I should say, because I already told you what it is. We have cars, which are a leading contributor to almost every air pollutant, every primary pollutant, and every air pollution problem. So they are like the biggest contributor to pollution is transportation. What primary pollutants do cars emit? That will, look at the diagram, because I gave you the diagram to kind of help me. Look, do you see carbon monoxide here? Yes, they do. But in this, you're right. So my cars will contribute every primary pollutant. But now we got to think, which ones are linked to smog? Okay, so what do we have here? I heard it, Jonathan? Nitrogen oxides, and volatile organic compounds, okay? Those primary VOCs, volatile organic compounds. So now I'm going to go back and show you why it's important to review, because I'm moving on, and I covered all the primary pollutants, and here's volatile organic compounds, okay? So you have to know them. So now we're going to talk about these problems from these pollutants. So we've got nitrous oxide and volatile organic compounds react with what? No, they produce that. What's reacting with it? So cars are producing this. What's reacting with it? What's coming in? Sun. The sun reacts with them and it forms. So this is coming out. And you said oxygen. Is O3 oxygen? What is it? Ozone. And ozone is a secondary pollutant. When it's in the troposphere, it's highly toxic. So already this reaction is causing toxic levels of ozone in the troposphere, which actually break apart. So the nitrogen is still around, right? The hydrocarbons are still around. And they form what's called PANs, which they'll come up on the AP exam. So when you see the word PANs, you want to think of photochemical smog and directly linked to nitrates because they're peroxyl nitrates or some form of nitrate, which causes this brown haze across urban areas, which is what we call smog. So everybody knows acid rain. They've heard that concept. But in environmental science, it's called acid deposition. because we know acid rain only describes water falling down, and it could fall as snow particles, hail, sleet. It can even fall dry. So that's where it goes from acid precipitation to what's called acid deposition. So you can have dust particles, right? So water, I'm going to tell you the process, but then it becomes dry particles that are highly acidic that could fall on land. So that's called acid deposition, okay? How does it happen? Here it is. So we've got, again, cars or burning of fossil fuels produces what? We're going from here, burning fossil fuels, producing what? VOCs. What do we got? Nitrogen oxides. There's no VOC there. Sulfur dioxide. So those are my two primary pollutants that are linked to acid deposition. And here's the bigger name for it. They react with what? Good. What's in precipitation? So precipitation comes down. These are reacting with what? Water. And they form acid deposition. In this case, I'm showing you acid precipitation, which contains what chemicals in it? So it's no longer H2O coming down. It's what? So when you put an H in front of a formula, what is it called? What does it turn into? An acid. So this would be what? Blank acid. Sulfuric acid. And what's my nitrogen acid? Nitric acid. Good. So you don't have to know the balanced equation of this, but you do have to know the reactants, nitrous oxide, sulfur dioxide, water, right? And the product is sulfuric acid and nitric acid, which can come down in rain, hail, dust, all of these things. So although this is a problem in the troposphere, okay, we're emitting high levels of sulfur and nitrogen into our troposphere, the problem really falls on where does this precipitation or deposition land. So before we talk about the problems that it arises from, let's review the pH scale. The lower the number, the more what? Acidic. What's normal rain according to this pH? 7. Look at the picture. Rain. So normal, what we call neutral pH is 7. Normal rain is 5.6. Acid rain would be below 5.6. Okay? So anything below 5.6 is considered not normal rain. So it's acidic levels of rain. So think about it. We have a lot of levels of defense, but a lot of organisms don't. Okay? If high levels of pH fall into an aquatic biome, there's organisms in an aquatic biome that you alter their pH and immediately they go into like shock. I mean, some organisms have tolerance ranges, but if the precipitation falls in a large quantity to the point where it could transfer the pH of the whole biome, organisms in the biome are going to die. In addition, we're going to affect soil, okay, because precipitation falls on land, which is going to affect crops because crops are taking in all the nutrients from the soil, and if the nutrients are highly acidic, the crops become acidic, food chains will be affected. So think of the indirect effects, right? And then a lot of problems with structures. Mostly it's like the visual of the structure at first, you see structures showing those green, but then it's deterioration, which leads to buildings losing parts and things like that. So there's a lot of damage. Normally people ask, does it affect humans directly? And the answer is no. We have buffering and we can, you know, kind of, now if you open your mouth and start drinking it, I'm not sure, I can't believe